Today, we're diving into a really big deal in the world of AI efficiency. It's a new technique from Google Research called TurboQuant, and it has the potential to completely revolutionize how AI uses memory, making it way faster and more powerful. So let's get right into it.
So, you ever notice this? You're deep into a chat with an AI, maybe you're brainstorming or writing a story, and it just starts to slow down. Or worse, it seems to forget what you talked about 10 minutes ago. Well, that's not a bug. It's actually a fundamental and very frustrating memory problem. And the culprit, the technical villain of our story, is something called the key value cache. You can just think of it as the AI's short-term memory. Every single time the AI generates a new word, it has to scan this entire cache, the whole conversation history, just to figure out the context. And this memory usage isn't a small thing. It just explodes. As you can see, the longer the chat, the bigger the cache. It grows in a straight line, just eating up incredibly expensive GPU memory. Eventually, the AI slams right into what engineers call the memory wall. And that is the bottleneck that limits how much an AI can remember and how fast it can run.
But what if there was another way? What if you could have it all? What if we could shrink that massive memory footprint down to a fraction of its size, but, and this is the key, without losing any of the AI's quality or accuracy? Well, that's where our hero comes in. Meet TurboQuant. It's a groundbreaking new algorithm from Google Research that claims to do exactly that. This isn't about throwing more hardware at the problem, it's about using smarter math. And the claims here are frankly mind-blowing. We're talking a 6x drop in memory usage, which can lead to an up to 8x speedup on the best GPUs out there. But the real kicker? It promises to do all of this with zero measurable loss in accuracy. And it just works right out of the box. No need to retrain or fine-tune the AI model. Okay, so that sounds almost too good to be true, right? How on earth does it actually pull this off? Well, the magic is in a really clever two-stage pipeline. So let's look at stage one. It's called PolarQuant. And the whole idea here is to just look at the data from a totally different angle. Here's a great way to think about it. Imagine you're giving directions. You could say, go 3 blocks east and 4 blocks north. That works. Or you could just point and say, go 5 blocks in that direction. The second way, using a distance and an angle, is often a much more efficient way to describe the same point. That's basically what PolarQuant does with the data. So here's how that magic trick actually works. First, it separates the data's overall strength. You can think of it like its volume, and just stores that separately. Then comes the secret sauce. It performs a random mathematical rotation on the data. Now, that sounds complex, but all it really does is spread the important information out perfectly evenly. Once the data is that uniform and predictable, it can be compressed or quantized incredibly efficiently. But just compressing the data isn't quite enough. Stage one is great, but it introduces a tiny systematic error into the math. And for the AI's attention mechanism to work perfectly, that math has to be precise. So that's where stage two comes in, the QJL Bias Fix. You see, these two stages have totally different jobs. PolarQuant's goal is simple, make the compressed data look as much like the original as possible. But QJL's goal is much more specific. It acts like a little mathematical error checker, going in and cleaning up those specific calculations that the AI's attention relies on, making sure it pays attention to the right words in the conversation. So on paper, you've got this beautiful, elegant two-stage theory. But when the open source community got their hands on TurboQuant and started testing it in real large language models, they discovered a really surprising plot twist. It turns out there's a part of the AI's attention mechanism called softmax, and it basically acts like a massive amplifier. That tiny random bit of noise introduced by the perfect QJL error checker, well, it got amplified into a huge problem. Ironically, the first stage, PolarQuant, even though it was technically less perfect, had much lower noise to begin with. So after going through that softmax amplifier, its cleaner signal actually produced way better results. For these AIs, it turns out stage one alone was the real winner.
Okay, so keeping that little twist in mind, what is the actual real-world impact of a technology like this? Well, to put it simply, it's enormous.
Just look at the speed. On a top-of-the-line Nvidia H100 GPU, using TurboQuant delivered an 8 times speedup for the attention calculation. And since that calculation is the main thing slowing down long conversations, this is an absolute game changer.
Now, TurboQuant isn't the only game in town. Nvidia has its own method called KVTC that can actually compress data even more. But they're really designed for different jobs. TurboQuant is like a drop-in solution for real-time chats that works with no setup. KVTC is more like a JPEG for AI memory. It's fantastic for storing things offline, but it needs to be calibrated for each specific model.
And the shockwaves weren't just technical, they were economic. The day after Google announced TurboQuant, the stock price of Micron, a massive memory chip manufacturer, dropped by 7%. The market immediately understood that a single clever algorithm could drastically reduce the demand for raw, expensive hardware.
And that right there is the big takeaway. For the past few years, the story of AI progress has been all about brute force. Just build bigger data centers, buy more GPUs. TurboQuant is a huge signal that that's changing. It proves that an elegant piece of software, a mathematical breakthrough, can be just as powerful, maybe even more powerful, than just building bigger buildings.
So that leaves us with one final exciting question. Now that this massive memory constraint is starting to ease up, what new things become possible? Could we build AI agents with near-perfect lifelong memory? Or AIs that can read and understand an entire library of books in a single pass? The future of AI just got a whole lot more spacious. Thanks for joining me.